Hello, I'm Walter Barta. I'm a graduate student at University of Houston, and today I'm going to be talking about some loopholes in the Impossibility Theorem for Welfarist Axiology. So the first question is, what is the welfare impossibility theorem? Well, it's a theorem developed by Gustaf Arrhenius originally around 2000 and has since undergone a few different revisions. But it's a theorem that states that welfarist axiologies of a certain kind are impossible. The theorem reads, there is no welfarist axiology that satisfies the dominance, the addition, and the minimal non-extreme priority principle, and avoids the repugnant, the sadistic, and the anti-egalitarian conclusion. So what does this mean? Well, the dominance, the addition, and the minimal non-extreme priority principle are three principles that Arrhenius thinks a welfare axiology should require. And the repugnant, the sadistic, and the anti-egalitarian conclusion are three conclusions that Arrhenius thinks that a welfare axiology should avoid. But when we combine these six criteria, we result in a contradiction. And therefore, welfare axiology is impossible, at least according to these six criteria. So what I'm going to be doing in the rest of this presentation is arguing that at least two of these assumptions are incomplete. And therefore, the welfare impossibility theorem doesn't apply to welfarist axiologies that we should be interested in. So, the first thing we want to do is we want to understand how Arrhenius's proof works. So here we have a mock proof of welfarist impossibility. So we can see that we have six premises, and they are the principles that are required and the conclusions that must be avoided. So we have the addition principle, the minimal non-extreme priority principle, the dominance principle, and we also have a requirement of no repugnant conclusion, no anti-egalitarian conclusion, and no sadistic conclusion. But when we put all six of these premises together, we arrive at a contradiction. That's why Arrhenius thinks that welfarist axiology is impossible. But how does this proof work? Let's look at a simplified proof structure to understand what Arrhenius is doing. So here we have three premises, and each premise is an inequality statement. So we have A is greater than B, B is greater than C, C is greater than A. Now, if we assume that all three premises are true, we can arrive at a potential contradiction. We say that A is greater than B and B is greater than C, therefore A is greater than C, but also C is greater than A, which means that A would be greater than A. And obviously, that is a contradiction. So Arrhenius's proof is significantly more complicated than this, but it follows the same basic structure, a sequence of inequalities that result in a contradiction. To get there, Arrhenius makes a few different stipulations. First, he stipulates that there are some populations. He defines M, P, and Q to represent populations. He also stipulates that there are some average welfares that the persons in these populations have. So W5 through W0 are average welfares of populations. And he stipulates that there are population betterness in these different populations. So AP through E1 are representative of the population betterness of different populations. So Arrhenius combines these stipulations and results in a proof. It's a 15-step proof that is a sequence of inequalities resulting in the last step in a contradiction. Now, as you can see, the proof is quite complicated, and we aren't going to go through every step of the proof in order to understand it. But that's okay, because we can focus only on a few steps in the proof, specifically those steps where we can identify potential loopholes. And that's what we're going to be doing for the rest of this presentation. The first step that we're going to be focusing on is step 7. And we're going to be asking the question, is the addition principle too broad? And we're first going to be running an ordinal critique, which is to say we are going to be comparing the population betterness of certain populations against the population betterness of other populations. So here we have step 7 as it is laid out in Arrhenius's critique. Each rectangle represents a population. The width of the rectangle represents the size of the population, and the height of the rectangle represents the average welfare of the population. This particular sequence of rectangles represents the addition principle, which states that if it is bad to add a number of people, all with welfare lower than the original people, then it is at least as bad to add a greater number of people, all with even lower welfare than the original people. We can see the application of the addition principle in this sequence of rectangles. We see that AP is on both sides. On the left side, we add population B, which has a lower average welfare than population A. And on the right side, we've added population C, which has an even lower average welfare than population B, and also is a larger population. So, as the addition principle states, the addition of B must be greater than or equal to the addition of C, because C is larger and worse off. However, this application of the addition principle should give us an intuitive suspicion, namely that the comparisons of the added populations seem to depend greatly upon the size and sign of the added population and welfare. What does this mean? Well, for some sizes and signs, the comparison seems true. So here we have an example where rectangles A and B do seem greater than or equal to rectangles A and C. You can see this by just eyeballing the sizes of the rectangles on the left and the sizes of the rectangles on the right, and seeing that the area of those on the left seems to exceed the area of those on the right. But for some sizes and signs, the comparison seems false. So here we have a different example. And in this example, A and B do not seem to be greater than or equal to A and C. We can see this just by eyeballing the rectangles on the left and comparing their areas to the rectangles on the right. So we should be worried because it seems like the addition principle applies to some population comparisons, but not to other population comparisons. To better understand this, let's look at two different cases. We'll look at the first case, which we'll call the solely sad babies case. In this case, we have one baby living just one solely sad day. And we'll compare that to two babies, each living two slightly sadder days. Now this case, we're going to compare to the barely happy babies case. In the barely happy babies case, we are thinking about one baby that lives for just one barely happy day and comparing that to two babies that live for two slightly less happy days. And what we can gather by comparing these two cases, the solely sad babies case versus the barely happy babies case, is that negative addition is worse. So in the solely sad babies case, it seems certainly worse to have two babies living two sadder days than it is for just one baby living just one solely sad day. However, positive addition is uncertain. It's unclear that one baby that lives for just one barely happy day is better or worse than two babies that live for two slightly less happy days. In order to determine whether the one baby is better or worse off than the two babies, we would have to know something about the relative welfare of the one baby versus the relative welfare of the two babies, and we would have to make comparisons based on that. If we don't have that information, it is uncertain whether the addition of two babies is worse than the addition of one baby. So, the addition principle seems to apply in the solely sad babies case, but does not seem to apply to the barely happy babies case. It seems that the addition principle only applies in cases with negative welfare. So, taking this into account, we can make a modification of the addition principle. The modification is something we can call the negative-only addition principle, which says if it is bad to add a number of people, all with welfare lower than the original people, then it is at least as bad to add a greater number of people, all with even lower negative welfare than the original people. And we can see what this might look like by turning these positive rectangle populations into negative rectangle populations. Whereas the positive case was uncertain, the negative case seems clear. The addition principle that is negative only does seem to apply. We can see this by eyeballing the left side of the comparison and subtracting population B from A and comparing that to the right side of the comparison and subtracting population C from A. When we do this, we see that the left side of the equation seems to be clearly greater than or equal to the right side of the equation. We can also show this by making a cardinal critique, which is to say, critiquing not in terms of ordinal betterness relations, but critiquing in terms of cardinal numbers that can be added, subtracted, multiplied, and divided. The cardinal critique will come down to a question of relative shapes. We can consider a rectangle B that has a width of WB and a length of LB, and a rectangle C that has a width of WB minus X and a length of LB plus Y. We can ask ourselves the question, can you tell which rectangle has a larger area, B or C? And the answer to that question is going to be no. You cannot tell which rectangle has the larger area because first you would have to know the values of X and Y. That would determine whether or not B is greater than C or C is greater than B. And a similar thing is happening in our population comparisons. You can't tell which set of populations will be greater than or less than the other set because you haven't defined certain features of those populations. We can show this via a proof. We can take step 7 and then cancel out from both sides the value of W5P. Then we can rearrange the equation so that W4 is on one side and everything else is on the other side. We can then stipulate an arbitrarily large population M where M is approaching infinity. When we do this, we can see that W4 must be greater than or equal to W3 times infinity. This would seem to require that W3 be less than or equal to 0, but we know by stipulation that W3 is greater than 0. Therefore, W3 both has to be less than or equal to 0 and greater than 0, which is a contradiction. So now that we have shown step 7 to result in a contradiction, we can return to Arrhenius's proof and mark step 7 as untrue. Step 7 seems to be necessary to the overall proof because steps 5, 6, 7, and 8 constitute a subproof resulting in step 8, which is a contradiction. So the next thing that we can ask is the subproof still valid? And we can ask this by looking at step 8. We can see that step 8 is a repeat of step 7. When we apply the addition principle that we modified in step 7, we are required to make population C have a negative average welfare. But if we compare then the populations on the left side of the equation with the populations on the right side of the equation, it seems obvious that the inequality will hold. Those on the left side are greater than those on the right side. We can see this by eyeballing A and B and eyeballing A and C, and then subtracting C from A. So it would seem that step 8 is still valid. So returning to Arrhenius's original proof, we can mark step 8 as true, even though we marked step 7 as untrue. So our criticism of step 7, while a valid criticism, is not destructive to the proof as a whole because we can still arrive at step 8. So if we are going to try to undermine the whole proof, we are going to have to look elsewhere. The next place we're going to look is at steps 2 through 4, and we are going to ask the question, do the no repugnant and no anti-egalitarian assumptions conflict? And the first thing we're going to do is we're going to look at this in terms of an ordinal critique comparing the population betterness. So step 2 is a comparison of population A to population D, which says that there must be some population A greater than or equal to population D. And we arrive at step 2 via the no repugnant conclusion condition, which says that for at least one perfectly equal population with very high positive welfare, there is no population with very low positive welfare which is better. So applying this in step 2, we can see that if population A is the population that we're talking about, the perfectly equal population with very high positive welfare, then population D must be less than or equal to it, according to the no repugnant conclusion condition. Next, we can move to step 3, which says that population D has to be greater than or equal to population A and C. We can arrive at step 3 because of the no anti-egalitarian conclusion condition, which states that a population with perfect equality must be better than a population with the same number of people, inequality, and lower average and thus lower total positive welfare. So applying the no anti-egalitarian conclusion condition to step 3, if D is a population with perfect equality, then it must be greater than A and C together if A and C together have a lower average welfare and the same population size as D. In other words, the perfectly egalitarian population D must be greater than or equal to the same sized population with large inequality, and that is of an average welfare less than D. Next, we can move on to step 4, which combines step 2 and 3 via the transitivity principle. So we can see that when we have the no repugnant and no anti-egalitarian conclusion condition together, we can say that at least one perfectly equal population with very high positive welfare must be better than a larger population with inequality and lower average positive welfare. We can see that this is true in step 4 by seeing on the left side of the equation that population A must be greater than or equal to population A and population C. However, this should lead us to an intuitive suspicion, because this result seems to suggest that adding a positive welfare population C to a positive welfare population A is worse than or equal the original population A. It should be obvious just how implausible this seems if we compare the left and right sides of the equation. Eyeballing the left side of the equation, which is just population A, and eyeballing the right side of the equation, which is A and C, it seems obvious that A and C would be larger than population A by itself. Indeed, it seems strange that adding a positive population to A would be not as good as just A. We can explore why this seems intuitively wrong by looking at 2 cases. The first case we can call the sad poor island. In the sad poor island, we have a small, well-off upper class and a large, unhappy lower class. And we can compare that to just the small, well-off upper class. We can contrast this case with another case that we can call the happy poor island. In the happy poor island case, we have a small, well-off upper class and a large, slightly happy lower class. And we can compare this to just the small, well-off upper class. So, what can we conclude from these 2 cases? The first thing that we can conclude is that negative inequality is worse. We can see this because in the sad poor island case, it is not clear that adding the unhappy lower class makes the population better off overall. It seems like the small, well-off upper class by itself might be a good population, But by adding the unhappy lower class, we might have created a bad population by the addition of that inequality. But we can also conclude that positive inequality is better or uncertain. In the happy poor island case, it seems like the addition of a slightly happy lower class could improve the overall population. So, comparing these two cases, we can see that step 3 must be mistaken. Step 3 would only apply in cases of clearly worse inequality, but would not apply in cases of clearly better inequality. So we can return to our comparisons and we can modify one of the steps. Namely, we can modify the anti-egalitarian conclusion. And we can call this modification the negative inclusive anti-egalitarian conclusion, which says that a population with perfect equality can be worse than a population with the same number of people, inequality that can conclude populations of negative welfare, and lower average and thus lower total positive welfare. Modifying the anti-egalitarian conclusion to be negative inclusive changes what step 3 must look like. Rather than having the population C as a population with a positive welfare, we can have population C be a population with negative welfare. And this makes more sense because it's clear that population A would be greater than or equal to itself and a negative population. This is clear just by eyeballing the left side of the equation and eyeballing the right side of the equation and subtracting the area of rectangle C from the area of rectangle A and comparing the left side to the right side. It's clear that the left side should be larger. We can also arrive at this conclusion via a cardinal critique. We can think of this in terms of what we will call self-sizing shapes. Considering a shape A that has an area greater than or equal to its own area plus the area of some other shape C, we can ask ourselves the question, is this shape possible? And it seems clear that the answer is no, because adding a positive shape to a positive shape will be greater than either of the constituent positive shapes. The only way that adding a shape to another shape could be less than one of the original shapes is if the addition is actually a subtraction. We can show this via a proof. So starting with steps 1 through 4 of Arrhenius's proof, we can continue by canceling out the value of W5P from both sides of step 4, and then by simplifying by setting the population value m plus q greater than 0, and arriving at the conclusion that W3 must be less than or equal to 0. However, by stipulation, W3 is greater than 0, and so we've arrived at a contradiction where W3 must be greater than 0 and less than or equal to 0. With this, we can return to Arrhenius's proof, and we can mark step 3 as untrue. But does marking step 3 as untrue invalidate the entire proof? In order to determine that, we are going to need to jump down to step 13, where the dominance principle is applied. And here in step 13, we're going to ask ourselves, is this application of the dominance principle invalid? In step 13, the dominance principle is applied by comparing population A and population C to population G, and saying that A and C must be greater than or equal to G. This must be true due to an application of the dominance principle, which says that if population A contains the same number of people as population B, and every person in A has higher welfare than any person in B, then A is better than B. So applying this to step 13, we can see that population A and C together have the same size as population G, and we can see that population A has a greater average welfare than population G, and that population C has a greater average welfare than population G. Therefore, by application of the dominance principle, A and C together must be greater than or equal to G. However, according to our modified step 3, W3 must be less than or equal to 0. This changes what step 13 must look like. Now, population C with an average welfare of W3 must be negative in its average welfare, according to our modification. But as we can see, this modification makes step 13's application of the dominance principle invalid. We can see this because population C now has a negative average welfare, which is less than the average welfare of population G. So, with this in mind, returning to Arrhenius's proof, we can mark step 13 as untrue. We also can notice that step 14 requires step 13 and an application of transitivity, because step 13 is untrue. That transitivity should not be able to be applied to step 14, which means that we can say that step 14 is untrue. And we can further notice that step 15 requires step 14 for a contradiction. But because we have said that step 14 is untrue, we can't arrive at the contradiction in step 15, so step 15 must be untrue. So, as we have shown, Arrhenius's proof of the impossibility theorem of Welfarist axiology is undermined if we make some rather intuitive and straightforward modifications to the principles that he is assuming. If you are interested in exploring the full text of this critique of Arrhenius's proof, or if you're interested in a positive proposal for Welfarist Axiology, you can look at the documents on my account at philpapers.com.